So I'm recording from OBS and streaming at the same time. So we're good to go. So, okay, welcome. This is gonna be experimental and a lot less formal. It's not the public stream, so it's easier to go through. You guys can interrupt me with any questions, either here directly just saying something. I'll stop talking and I will answer the question as best as I can. And you guys can also ask anything in text on the beta channel, whatever, that I'll try to answer as we go. So the topic today is moving platforms. So before I explain anything, I'll just show some things working. So that's best way to show these things. So I'll show it here working, and it would look like it's easy to do, but it's kind of misleading because I'm running here. I'm gonna run here as a host, so I don't have any rollbacks. I don't have any, let's say, remote player that I'm interpolating. The way Fusion works, the server only moves forward, so the server never rolls back. It never gets clients in the past or anything like that, so it only moves forward. A curiosity here for if you guys that don't know, so Fusion is in, I would say, very good company. There are two modern games that use this exact same model that we know of. They are Valorant and Overwatch. Some other, let's say, very good netcode games with very good netcode, they use some more weird models like CS and Unreal has a super strange legacy system based on time that they don't dare to touch because it works for them, but it's not really intuitive or easy to work with. But so we really like this model that we came up with, that the server never rolls back, the server only moves forward with a fixed time step, tick-based simulation. And what the clients do is clients predict ahead of time compared to the server to be able to send input in time to the server. There is no speed hack possible because the inputs that the client send to the server are also tick-based. So the input either gets to the server or it doesn't get to the server. And so clients move ahead of the server. When the clients receive receive state confirmations back from the server, that always rolls back the full Fusion game state or a partial Fusion game state if you're running eventual consistency mode and you have area of interest management in general enabled. It always rolls back that and reconciliates, which means the client resimulates forward all the way to what is the predicted present for itself, maybe even simulating a new predicted tick and so on. So the clients always roll back and move back forward to reconciliate what the server sent as confirmation. So this is a very clean model, and it lets you predict anything. So we'll see here. So we're gonna talk about moving platforms today, and there are 3 different ways to handle moving platforms, and you can do all 3 of them with Fusion easily because you can predict anything. You can predict the platform. So that's what we're gonna be experimenting with today. Anyway, so you guys see here on my screen, the whole thing is working as it should, but this is a bit like a single player game because this is the host. It's only moving forward at 60 ticks per second, and the visuals are also interpolated to whatever is my rendering rate. I think I'm not running this sync, but this screen is 60 Hz anyway, so it's actually locked to 60 Hz on the rendering. But it's smooth and it's working, and I can jump into that, into this one here, which is a platform that moves sideways, and you see that it's pretty stable. I don't get out of the platform, I don't slide, I don't do anything crazy, and also the animation is not changed, and it works fine. So this looks okay. This can be solved, right? So it looks correct, but it's not so easy. So I'm gonna explain a few things here, and then we're gonna experiment this with the builds as well, and then we'll see that things break. So first, a few things here. Let me see where I should write stuff that lets you guys, that may let you guys understand better. So I'm going to use this one here. So is this readable?
Yes.
Okay, good. So here's the thing. So if you guys don't know, what the server does is the server only moves forward. So it's time to simulate tick 100, server simulates tick 100. Then it accumulates delta time with whatever is the loop that's running on the server. If it's a dedicated server, or if it's a client, a player working as a host. When it's time to simulate the next tick 101, it will do it. If players have sent input in time, that's going to be used on the server. And the data confirmations for all these ticks are going to be sent down to all clients that has to see about that. If it's delta compression, delta snapshots, it's going to be sent the whole delta snapshot for everybody. So that's how the server goes. So server only moves forward. But what happens on clients is slightly different. So the server technically keeps a buffer of previous states because it needs to compute new deltas for, let's say, every time it needs to send a full delta snapshot, for example, for any specific client, the server may need to delta that against tick 98 or so on. So the server actually keeps a buffer of these states, but it's not used for anything else. It's only used for the state transfer, which is something that you never touch in the code. You don't have to worry about that. But technically, we also keep two of these frames on the host as well, because everything you look on the screen is smoothly interpolated between the last two ticks by default, or you can, if you want, extrapolate yourself on the rendering to make sure it goes very snappy with the rendering rate. This is exactly what I do, for example, with the camera rotations and on the FPS camera setup. I extrapolate the mouse movements so the camera feels how it should in this particular sample here. But on clients, it's a bit more interesting because you normally, and this is very peculiar for shooters. So, I mean, not only shooters, but this, I'll just show how it goes here. So let's say when the server is, so this is a good example here. So the server just simulated tick 102, right? So the server has this here. The client probably has as the latest tick from the server, let's say the client has tick 98. But technically, we don't even show on the client proxy objects that you'll see from other players. They're not locally predicted. You don't even see them in tick 98. You probably see something like in between tick 96 and tick 97 or so. Because this here would be your interpolation window. So this is your interpolation window because the point is that the tick that you receive from the server, it may jitter because of network reasons. So this is a fact. So this is just how it is for networking. So the tick you receive, they do not come very steady. They come with some jitter. And it's not because the server does not process them in time. The server does it very steadily. If you dump the network sends from the server, they're going to be very steadily sent in time. But there is ping jitter in the real world on the internet. So you're going to receive 98, 99, 100, not exactly in the perfect pace. So you never can really interpolate what you see from other players exactly at the last tick you received from the server. So I don't know if you guys knew this, but technically you are seeing a little bit behind the latest data you actually have on the machine. that's just to make sure you see something absurdly smooth. But here are a few things. For example, creating an interpolation window from confirmed data from the server is not difficult. What is difficult is to tickle the tail of the dragon, which is how can you make the interpolation window be as close as possible to the latest data tick you have from the server and still make it be smooth enough that it doesn't jitter on when network is not super stable. So in general, you're talking about like at 60 hertz, you're talking about like 2.5 ticks in average behind the latest data you have from the server. But this is something we normally don't tell a lot of people, but here it is. This is the number that you guys are seeing in Fusion. So have you guys ever seen those NVIDIA setups that you can use to record the time for something to register on another machine? So you shoot on your machine, and seeing the local hardware delay is one thing. That's very fast here. It's just the aliasing between the rendering and the tick rate. But how long does it take to actually go all the way to the other machine, the other player, and you see the thing happening there? So that's the total delay for something to show up. So to reduce that to a minimum, you have to render stuff very close to the latest tick you get from the server, even for interpolated stuff. And Fusion is normally giving you this number here, 1.5 below the latest tick you have at 60 hertz, and this is very, very low. So if you have one of those NVIDIA setups, or you can do with a camera filming two machines at the same time, you're gonna see that you can record stuff very, very, very fast, very close to the hardware, to the actual observed RTT and so on. So let me see if this is a question here. Devin, today it is here on Discord. I'm live on the audio channel here. Okay, so enough talking about this. It's pretty low. So Alex, maybe remember that you were a bit you were reporting a few things when running the simulation at 10 hertz. So at 10 hertz, this is tricky. So this is what we're investigating, how low you can go. But we've tested it before. But maybe it's the 1.5 thing. It's too aggressive when running at 10 hertz because the server is sending at 10 hertz as well. So it may be just a case that you need to tweak the interpolation parameters to make this window be a little bit far from the actual tick head that you get from the server, right? But let's move on here for the next topic. So say this is so 98 is the latest data we have from the server at the time that the server is simulating. Let's round things down here to server is simulating tick 100. Tick 98 already reached the client. The interpolation window is currently at 96, 97, or let's say 95, 96 to be a little bit further from the head tick. Then, depending on how your RTT is, your round trip time is, the predicted ticks you have on your machine are gonna be, they're not 100. They're gonna be, I don't know, 102 and 103. So this is the head tick you have from prediction, and this is the previous one. So here's the interesting thing. I keep talking about dual timing all the time, right? I keep talking dual timing. So if you guys remember here, you can set the default components from Fusion that synchronize stuff like network transform. you can set this thing here called interpolation data source. So this thing here, if you set to auto, you will use predicted timing for objects where the local machine, I mean, it's always predicted, quotes, timing if you are the host, right? So that doesn't really matter. But if you're a client, auto here means that you interpolate in predicted time if you have input authority for the object. And you interpolate in the interpolation, snapshot interpolation window from the data that you have confirmed from the server for objects that are proxies, that you are not input authority for. That's what auto mode does. But you can also force things to interpolate always from snapshot interpolated data, which is the delay data from the server, or you can force things to always use the data from the predicted ticks, the latest two predicted you have. So just to make sure you guys understand. So what that means is, here in our timing thing, is that if you're doing snapshot interpolation timing, what you see for that object is around A here. Is between 95 and 96. It goes smoothly between 95 and 96 with your rendering. So it's going to be aligned with your rendering more than with the tick timing, so it advances with your rendering. And for predicted objects, you're going to see at B, somewhere between 102 and 103, aligned with the rendering time you have past 103. That's easier. So it's the accumulated delta you have past 103, but that's not enough yet to simulate 104, so you're interpolating between 102 and 103. It is possible to also do C. So C is extrapolated with the rendering. This is what I do for the camera rotation in this game here. And this is what we do for the character controller that Erick implements, the advanced character controller. It actually renders and moves with the actual logic at the rendering rate as an extra extrapolated prediction on the clients for the local player, right? But going back to what matters to us here. In shooters, we normally use this dual timing setup, in that we always use for the local player either B or C. And the reason for this is because B or C they feel really good to play at. So, hey Chris. So B and C feel snappy, they feel good to play. If you just use A all the time, it feels slow. It's not fun to play. So it's super common to use this setup here. And the problem then it's, okay, so why don't we predict everything? For example, Quantum by default predicts everything. So in Quantum, you are normally using B for everything you see, for physics, for remote players, because we are based on inputs. We have input for all players, and we can more or less predict what the players are going to do, because people don't change what they're doing super fast. And when they do, we have an error correction algorithm that smoothly fixes the visuals anyway. And there are famous super good games that use everything in predicted timing. The most famous example is Rocket League. And but you can also think here, every fighting game that uses predict rollback netcode normally renders stuff at B, so in predicted timing. So why don't shooters use B and C for everything? Why do they only use B and C for the local player? The reason is the first thing is B and C are the things that feel good. So why don't you put everything on time B? Why don't we also predict the movement of the characters that are close enough for us, so we see them in present time, predicted time? That's what Quantum does, for example, even if you build a shooter in Quantum. But the point is, there are two things. First one is that it's very expensive to predict and roll back everything. So if you have, for example, a game with a lot of characters and you want to predict all of these characters, it will get very expensive to predict animation for everything, to predict movement for all of these guys. So this is not really feasible. That's one reason. But we have people here doing games with full prediction, and you see, yeah, you have Rocket League. If you have a physics-based game, that can really work and work well. But there's a second reason why shooters in particular always use dual timing, or most of the time use dual timing. And the reason is that it feels good to move and press the shoot button with prediction, but it does not feel good to shoot others if they're also in time B. And the reason is because people move really fast. And in shooters, especially competitive grade shooters, people move really fast. And because people do rocket jumping, people do zigzagging, randomly doing all that and so on, and it becomes very difficult to hit anybody if what you see is predicted timing. So throughout history of competitive shooting, dual timing became easier because you can do something interesting, which is, okay, what if I see the player in my screen somewhere smoothly, like timing A, and I shoot it, it felt good because I aimed correctly and I shot it, why don't use this? So keeping the players without prediction, without having to fix for mispredictions. Also, I forgot to mention this, also makes things very smooth if done correctly. So the point is, it's always smoke and mirrors. You want the players to feel that the game is real and it's smooth because, yeah, it's people moving around, etc. But I also want to shoot and feel that I can hit people. So you want to be able to aim at what you see, and what you see is in the past, and because the other option would be, let's say, difficult to actually believe in because there are going to be fixes coming from the server. So you want to be able to do this. You see the character and you shoot at it, you are sure you hit it, that's what happens. So then, okay, you can use the client hit registration for this to solve this. This is what even Battlefield does today. But in the history of competitive shooters, because of cheating and everything else, etc., this is not very safe. So in general, what was developed was what you guys know as lag compensation. And today's topic is not lag compensation, right? I'm just mixing the things together because lag compensation is going to show up again soon as a problem for moving platforms, which is the topic today. I'm just preparing the context for what's to come. So the point then is dual timing, which is seen, it's necessary for shooters in particular because of the super fast action that you have on them, for two reasons. You need B or C for your local character because it feels good to move like that, to move immediately. And you use interpolated timing for everything that comes from another player because that's the best way to keep it smooth and at the same time give a consistent timing for you to compute the shots, even if you're computing them on the server by the means of lag compensation. So it creates a very straightforward formula to compute all these things correctly. So that's the setup we have. If you're building a shooter, you normally have dual timing. You are seeing on the screen something on a certain time and something on another timing. And then we come to the moving platform problem. So the point is, in dual timing you have local character at B or C and proxies at A. So here's the question: in which timing time should platforms be at? Anybody want to try an answer for this? Does anybody want to try an answer? I'm waiting. It's the same answer as always. It depends, right? It depends on your game. So there is not a definitive answer. There is not a single answer for this question, right? So it's complicated. So let's think about it here. What happens is this: if we place at B or C, local player is consistent. So if we make if we predict the movement of the moving platforms, the local player is going to be super consistent, because the position that the collider of the platform is going to be at when I predict tick 103 is going to be more or less, I mean, of course, subject to very, very small fluctuations on float numbers accuracy, but enough to be smooth. The prediction of the moving platform, and the moving platform algorithm is even deterministic, right? It doesn't depend on other players, unless there's somebody else who triggered the moving platform to start moving in a certain tick. But as soon as the platform itself is moving, the movement of the platform itself is fully predictable. It's not based on input. So the position that the platform is going to be at on 103 is going to be exactly the position that it will also be on the server. So the local prediction, if the physics things are done right, so I'm going to show you one thing you have to enable in Fusion for that to be correct. But it's one thing that I need to say. So all of the different combinations can be done with Fusion. So it's just a matter of tweaking your code and the configuration options to make sure you run the mode you want. So they are all possible. It's really about what you want to do in the game. So let's go back here. So when you simulate tick 103 for your local character, you can place the platforms exactly at the right position. They will be also on the server, because you can predict anything in Fusion, so you can predict the platforms as well. And that's going to be fine. So the local player is 100% consistent. But the problem is going to be for the stuff that you see that's behind the time. So other players are may look weird on moving platforms. So what happens is, using this option, let's say if the platform is moving left and right, what's going to happen is, in the middle of the movement of the platform, even remote players are going to look correct, although they're going to be offset. So you may see a character flying, kind of like behind, he's following the platform, flying in the air. And they kind of change position when the platform moves direction. So you see my platforms, they oscillate back and forth. So they're gonna move in position. I'll soon demonstrate this when I create a build for it. But so other players are gonna look weird on top of the platform, and the more ping you have in your machine, the worse this is gonna look, because the difference between these two timings, B and A, is gonna be bigger the more ping you have. So the other option is, if you place at A, local player will do incorrect predictions. So it's even worse, because your local player is going to be on the wrong position, and then it's going to be fixed. So you're going to have a rendering issue to fix, because you're going to have some jitter on the local player. But we can also test this. We'll see how it goes if we place the timing for the platforms at A. And notice that I'm talking here about the collider the platform collider and the platform component that lets my character move smoothly on top of the platform like I demonstrated here. So I'm gonna soon show the code for that. It's super simple, the code for actually making the moving platform influence the character controller to move with the movement of itself. That's kind of easy. So what we have to do is we have to make sure that we decide for the timing on the collider, but we also make sure to match the visuals of the moving platform to what we're doing with the logic, because that makes sense, right? So to use the same. So if you do A, that's even worse. But then we have an interesting option here. What if we play? So the problem is that we have a mismatch between what we use for the remote players and the local players. So what if we do, if we place proxy characters at B or C? That's an interesting answer, right? So the thing is, if you want to place the proxy characters at B or C timing, which means you are predicting the movement of remote characters, you have two problems here. You lose the smooth movement when they move, and more importantly, you mess the timing for your shooting, especially if you're using lag compensation. So the whole topic of the context I was talking about becomes moot. It's not. It doesn't work anymore. So, but we may try to do something here, which is we may try to use this option here only if a remote player is on top of a moving platform. But then it's still a bit complicated, because if this remote player is on a moving platform and I then start to predict at least the moving platform movement for itself, I still lose the lag compensation accuracy for this guy. So what I see of this character is not exactly what I'm gonna shoot at, because he's on top of a moving platform. So we may want to do this only if the moving... So technically, a complete setup should be something like this. Predict moving platforms close to local character. Keep any other moving platform in timing A, because that means that any other player on top of that, you just leave them there, because everything is going to be on timing A, and you don't have to deal with problems with shooting. But any moving platform that's close to the local character, you predict. And then you do the same for very close proxies on top of moving platforms. You will still lose. You have two problems with this. You will still lose the lag compensation shooting accuracy for these, but if the guy is on the same platform as you, you're probably gonna go for a melee attack anyway. So losing the lag compensation is not the worst thing. The more complicated thing, if you go for this here, is you're gonna have to deal with transitions. What do you do when an object goes out of this close proximity and you have to switch the timing between A and B? So these are really hard problems to solve, right? So what I planned to do here today was to write a code that's flexible for us to experiment with these three options here and demonstrate how they feel, and that's what we're gonna do now. So again, if you guys want to ask anything about what I just said, feel free, either on the beta channel or directly here. Just say, hello, I have a question, and it doesn't bother at all. I mean, I really like to answer the questions because it helps me feel a bit the direction to go. Okay, let's see what I can start with while I wait for a couple of questions. Let me see. Okay, just said okay. Let's take a look at the code that does this here, because if you guys, for those of you who have not seen it yet, so let me run it again here. So you have another player there on top. This is still like single player because I'm not yet running the clients. It's gonna break when I run with the clients, but the moving platform movement is stable. I mean, it's even on single player games, some people struggle to solve this, but it's not super difficult to solve for a single player game, right? So here it is, it's stable, the character is stable, it's very smooth, the camera doesn't shake anything, so it's interpolated, matching exactly all of them. So let's see the code for this. So moving platforms, they are here regular networked objects that the server is authority for, and I'm using the regular Fusion network transform here, and I have a script called moving platform where I set what is the movement range in the axis I want. I can even do movement in multiple axes here, it should work fine. And I have a velocity that they're gonna move at, and so on, and some networked variables. Let's take a look at the code here, because the code is this. I originally store the original position to check for the range and switch the movement direction when we reach the limits. One important thing here, I do that, I initialize these variables only on the state authority in this case, which is the server, because a tip here is spawned is not guaranteed to be called on the same tick for every client, right? So clients may receive, so if you join late and you receive an object that you didn't have, of course you didn't have, you're late joining, right? Spawned is still called. And the data that you have on spawned when you late join is whatever is the data for the tick you late joined at. So be careful with setting values from here. Of course, they're going to be overhauled by the server, but sorry. But it's much easier in this case here to initialize variables just on state authority, unless they are local variables, right? Sorry. So initialize these two network variables, fine. And here's what my fixed update network does. It's super simple. So if I'm either the state authority, the server, or I'm choosing to predict. Remember that I said that we could predict the actual change of the collider position of this guy. So I'm exposing that as an option here. That's totally local. So either if I'm a state authority or on a client, if I want to predict the platforms, what I do is I go ahead and check if my current position difference to the original position means I have to change direction in any of the axes here. So I do the check here on the axis, and and that does the job. There is an interesting aspect here. I move platforms before I move the players, because I make sure that their positions and especially their new velocities are updated if they hit the limit before I compute the movement of the player, because we're going to use this variable here to apply to the character controller. That's why the character controllers actually follow the moving platforms very smoothly. So if I'm predicting, I'm going to do it. And in the end, like you can do in Fusion, you have a network transform. So you can just set the transform position to whatever you need. And in this case, I'm just integrating velocity here with the appropriate delta time from fixed update network. This does not take care of any visual interpolation, right? So the visual interpolation that's going to be used will be the one that we have here. Because we're testing right now on the server, everything looks fine. But let me do a build here, and I'm gonna test on a build. And see what happens. my plan here now is I'm gonna run the server on the build, and we're gonna join from the client because we'll be able to experiment with all the different timing options on the client without having to rebuild. Ideally, maybe I can even keep the server running and just disconnect and connect back, and it should work fine. So just give it some time to... I didn't pre-build it. Maybe I should have done that.
No, I left a question on the
I'm checking right now.
And my mic was not working previously, so.
So that's a very good question, Alex. We thought about it doing what you're saying here, but we decided not to because there is an easy way for you to do it. So we do not give you input for other players. So this gives you a very easy way to do local prediction because you can do things like this. So this try get input for player only works in two machines. In the machine where this player is the input authority for this object, which is one client, and on the server if running in client server mode. And this also works in shared mode, so you can use the same input loop in cloud distributed authority, client authority mode. But this gives you a clear way to check, hey, is this the proper place to either do prediction or the authoritative movement with this check here. If you want to do prediction of other player movements, because a platform is as easy as this. I just apply the movement and the movement is being predicted here. But if you want to predict the movement of another player like this guy here, the way to solve that is you have to store the relevant inputs you need as game state. Because then when you receive a snapshot from the server is responsible for copying the input data for that player into the game state. And that snapshot is sent to the clients. So the client that's trying to predict that can just use the stored input. And that input's going to be kept over the prediction ticks. So you can just keep it doing that. If you want to extrapolate the input and predict even the input changes, you can. If you want to. So you just copy the relevant input data you need as part of the game state in a component. And that is very efficient. And essentially you are doing the same thing that Quantum does. You are locally predicting the input of every single player.
Yep, got it. So unless I implement that and just enable the force the prediction on the component, what's going to happen? Nothing special, right?
That's another very good question. So let's take a look at our tick stuff here, right? So if you force prediction on the prefab here, so you go here, yeah, I don't care. I'm not gonna use auto. I'm gonna use predicted here. What happens is you're forcing Fusion to use this timing here, B. But the point is that the data you have from the server for 102 and 103 for this particular character controller is whatever was the data on tick 98, which is the latest tick you received from the server. So that's what you're going to see here. If you force prediction of the visuals, you're going to see this data here.
That makes sense.
Unless you implement fixed update network in between here to actually do something for proxies as well, which you can.
Yeah.
I think we're gonna experiment exactly this today with the proxies on top of a moving platform. We'll see if
so it's gonna run the predicted ticks but do nothing basically.
Yeah, it would just render whatever is the latest tick you actually got from the server, which is not the same as these two here. It's 1.5 ahead, but it's still not correct, and it will not be smooth.
Yeah.
I mean, depends on your
That makes sense.
rendering, your simulation rate, right? So if you're going for a slow simulation rate for a massive game, it will be jittery. But that, as you saw, it's up to you. You can do it. It's okay. So going back here, we have our build. So let me see if everything is working fine. I'm gonna start a host here, and the host has this guy I can control, which is good because I can then. So I have my host here, fine. I'm gonna place my host character on top of the moving platform already. You guys don't see it because it's on the other screen, but it's exactly the same stuff you guys already saw. So what matters is what we're gonna do now. So I have it here just as a control thing. So let's try to join the same game. I have no idea what's gonna happen right now. Did I press? I think I... Ramon, did we test enough? We did test with clients, right? I think I have to switch my app ID again.
Can you hear me, Eric?
Yes.
I have the same issue.
Wait, start clients is actually if you're in shared mode, right? Or not shared mode, multi-tier mode?
Yes, I'm sorry. I saw the discussion. Thanks a lot.
Yeah, you're single.
I know what to do. I know what to do. Sorry about that. So is that fixed?
It was not in latest. I tried it.
Okay. Yeah, maybe Devin is working that right now. So I'm not gonna even change the server is still running, so I'll just... Hey, here we are. So here it is. So you don't notice much because here's the thing. We're predicting the colliders, but the visuals of these moving platforms are actually on interpolated time. So they're matching those two characters because those two characters are proxies for me. So they are matching perfectly. So let me see what happens. First, I want to see them from closer to make sure, to see if I'm actually correct here. I think I am. So let's see what happens when my character moves on top of one of these. It's not bad. No, it's wrong. So, yeah. See? Do you guys notice? That my feet are inside the platform and then outside and then inside and then outside. I believe you guys can notice that, right?
We can see it.
Yeah, so that's because these platforms are at interpolated timing and my character is desperately trying to do predicted timing. And it's actually doing a good job of reconciliating really well because the colliders are all off. The colliders are not in predicted timing yet. But Eric, you said that your code here for the elevator, which is the one that it's predicting here. Why aren't the colliders actually in sync? Because when Fusion is running the physics engine, that's a trick here. Unless I force it to use client prediction for the physics engine, it will not be synchronizing the transform data to the colliders on the physics engine because that's a bit more expensive, right? But because I'm not using actually colliders and rigid bodies, I can run full prediction here on the physics. This is just gonna make sure I sync transforms from the Unity transforms into the colliders on the physics engine every tick, including on resimulations. So I'm gonna try again now. I'll try to go on top of the elevator and it will still be wrong. but I should be consistent, so the colliders should be more consistent now. Yeah, so that looks worse right now. So this is exactly what I wanted to show, because now I'm actually predicting the platform collider, but I'm not predicting the platform visuals. So it's an interesting case here. I'm not predicting the platform visual, and I'm not predicting the other character visual. So the character and the platform, the other character, the proxy one, and the platform kind of match fine. But my character is pretty bad here, because I'm predicting now the colliders, but not the visuals of the platform. So now I'm gonna make the platform visuals also use predicted timing for the interpolated visuals. And now what shall look off are the remote players. Notice I'm running on a local server here. Can you guys see that the other player is already off? So one thing here, I'm running the server locally. So why is it that it gets better with time? I know why. I'm asking you guys. Why is it getting better with time? It's a bit better now, see? Although it's still off, the remote player. First, it's gonna look completely fine for my character now, because my character is gonna be, both the platform and my character are predicted now. So it's basically, except for the little jump that actually happens, this is part of the physics, this also happens on the server. So this little jump when the elevator switches direction actually happens, also on the server. But apart from that, my character is perfectly correct, because I'm now using B timing, which is full predicted for both the platform collider, the platform visuals, and my character. But the other player is not correct. The other player is actually diving into the platform and out of the platform. And actually it's not looking that bad. And the reason it's not looking that bad for the other player is because I have a very, very low ping here. I'm running a server locally. The server is on the same machine. If you add more ping, it's gonna look a lot worse. We should try that with debug mode. I think I'm running the release version of the libraries. And this is also the reason why at the beginning it was worse. It's because Fusion is a bit conservative at the first seconds of the game. It applies a lot of, it does not start at that very aggressive 1.5 distance from the head snapshot. It's a bit behind, and then it snaps to be very close to the edge as time passes, and keeps self-adjusting after that. But if you have real-world pings, this would look totally off, and we can try with lag simulation here. So it's not really a full solution yet. So we just tried this, which is the last one we did, which is at least good for our local character. We tried first this other option here, which is not a good one at all. And we'll try to adapt the other characters when they're on top of a platform now, to see what happens. Let's see what we can do here to make that. Notice that in reality, very, very seldom games even try to solve this. If you guys see Apex Legends, it doesn't have moving platforms. You have grappling hooks, you have ropes, you have all that, but you don't have, because you can make proxies in interpolated time all the time. You are not having two different characters on top of the same physics thing. If you see all these games, I mean, have you guys seen the new gameplay footage from Battlefield 2042? So that showed that there was one moment where they showed a moving platform, which was when the team got into an elevator. but the elevator is closed doors and very small. So they can probably do this solution, which is they make everything in local predicted time when you have everybody inside an elevator. That helps a lot because they made a very tight closed elevator. So that's one game design trick, to still have moving platforms in shooters. But it's a really hard problem. So you see, it's very seldom that a game actually tries to solve it. So let's see here. Let me see if I have any question from internal discussions here as well. Let me see if I have nothing. Okay. I'll get an input from the network. Yes, Devin complemented the answer here. It's also correct. So let's go here and try to solve with this more complex option here, which is we're gonna try to make the proxy characters at B or C, but I may have an issue here that I need to ask, because I'm not sure if we already enable a certain feature. Devin, can we switch? I think we can. Can I switch this here? Can I switch this at runtime from code? Do you remember that? I can open the code here and check. I think I can, but I don't want to. I'll just try. So let's see what we can do here. So here's the idea. What we're gonna do is we're gonna check. I'm gonna do a very dirty version here, which is I'm gonna store a boolean I'm on a platform. I'm gonna be very brutal here, very verbose for now. We can have a cleaner, more elegant solution later. But the idea is this. The server is gonna say, hey, this guy is on top of a platform. And what I'm gonna do here is that if I'm on top of a platform, I'm gonna predict the movement of the remote player without the input movement for jumping and for the horizontal movement. But that's going to enable me to predict gravity and, more importantly, platform movement on predicted timing. So this is what I'm going to do here, and I'm going to set that from... So I have a mess here because my callback is here, but what I'm going to do is if my character controller sees that I'm on top of a platform, I can set that variable on the server, or I can predict, it doesn't really matter. So I can keep setting that on platform equals true, and I will set that to false before computing anything. So I'll start by setting this to false here. So if I'm moving, I try to reset this, and then the KCC callback is gonna set it to true if I'm actually on top of a platform. It's gonna set it back to true. So if I run on prediction, this should work. So what I'm gonna do here is that, look at this, I'm predicting if I'm not proxy and on platform is false. So if I'm on a platform, I'm gonna predict the move. But I still don't have input because, like Alex's question, this actually doesn't run for proxies. But I do have a default direction here that lets me at least apply gravity and apply the platform movements. So we are predicting at least the basic movement of a remote character if this remote character is on top of a platform. So, and on the first call for this, it's because I'm receiving this from the server, and then on the subsequent calls, even the prediction is going to keep this value correct because I apply it here from the callback that I'm using for setting things. Oh, I didn't even explain how I apply the platform velocity, right? So I have to show this later. So there's one more thing I need to do, which is I need to switch the rendering mode. Because like Alex asked, if I just force all characters to be predicted, I would just be seeing tick 98 here all the time for proxy objects. I don't want to do that. I want to switch dynamically the rendering mode of a proxy to be predicted if the proxy is on a platform. So I'm gonna check here after the whole thing here. This is not, it's not the best place. I mean, the code is, I'm sorry, this is becoming a mess, but I like to implement the features. And so if I'm a proxy and if I'm a proxy, what I'm gonna do is I have my network character controller dot interpolation data source equals so if I'm a proxy, so on platform, if I'm on a platform, I'm gonna use prediction, otherwise snapshots. So I'm gonna switch. I have to check if this is available. If not, I'm gonna personally let it make you work tomorrow, but I believe it's already valid. So by the way, my server is still running, and I believe I can just, no, I added a new variable, so I have to create a new build. Damn it. It would break. But I can now go back to Unity, just make sure things are not breaking for everything. They shall not. And I'm sorry, we're gonna have to wait. We will have to wait for another build this time. Okay, let me just see that this is still working fine for. Oh, it's not. I made something. I made something wrong here. What is that I broke here? Yeah, it's broken for the other as well. Yeah, every time I touch a platform, it's breaking. Let's see what is wrong. I may. I'm on a server there, so. Devin, did you see any obvious mistake here? False could be a movement. It's gonna set it to true. This should not be causing anything anyway, because this object is not a proxy, right? So yeah, it's already broken. As soon as I touch a platform, it breaks. Do I have to initialize this guy? So if I don't touch this, oh, I know. I see that if you guys were students, I would be complaining because you guys didn't notice what is wrong. This logic here is wrong. I want to predict the movement either if I'm not a proxy, local or a server, or if I'm on a platform. So what was wrong was me, not Fusion, sorry. But good that I tested, right? So let's see if it's still all fine, all working fine here for everything. Yeah, the guy's on top, so yeah, it's all good now. All back working. So let's see how it goes for the proxies, experimenting with them. So running again the server build. That's going to be the last one. And we'll see how... Yes?
Can you briefly talk about the specificities of the network bool versus a normal bool? Is that better packed or something?
It's not better packed. It's just that a regular bool it's not really size defined on all platforms, and and we map structs in an interesting way in Fusion. So we need to use blittable types that are cross-platform aligned, and yeah, Boolean is a bit of a weird thing. So you have that in C++ as well, right? So what is a Boolean in C or C++? There's so many different definitions of a Boolean variable, right? So in the end, we just created a type that is aligned. I think Frederick's gonna solve by letting you use a regular bool at some point, but for now, it's this is an easier way for us to concentrate on other things and still give you a working bool.
So is it taking a byte or?
I don't know if it's a byte or a full word, because this is just memory. In terms of data transfer, it doesn't take a full byte, because of the way data compression works. So
yeah, the packing.
Yeah. I mean, EC is bit packing, and EC is bit packing, and delta snapshots is a special delta snapshot algorithm that's not bit packing.
Yeah. Okay.
So I have my server running. Let me see if what I have here is a question. Yeah, dots has the same issue with bools. Okay. So let's go back to Unity here. So I have my server running here on the other screen. The server view, you guys already know how it is. So let's see how the client looks here. I don't know if it's going to look correct. Let's see. if we pay attention very closely to the left side here, the scene view, especially at the heat up period, it will be the snapshot head is gonna be further from the actual data we have from the server, so it's easier to see the artifacts. But there, yeah, no, it's not good. Well, actually it is. It is quite good. There is an issue when the elevator moves down that we briefly lose the on-platform value, and that causes this glitch. But this is specific to an elevator platform, and it can be fixed with an overlap, with an extra overlap, because it's something that our more advanced character controller does. That's interesting. But let me see if I can push that guy. Well, I don't need to push it out. I just need to move it from the server. So did you guys notice that this is much better now? So this is a remote player, and it's because it's on the top of a platform, we're predicting its movement. But as I said, we would lose lag compensation here. So shooting this guy would be a lot more challenging, because he's not really where he is here if you use the lag compensation system. But it's a lot better visually, and we can definitely fix the glitch on the top of the elevator. And the most interesting thing is there is no glitch for the horizontal moving platform. So this guy is fully predicting the platform movements on top of it. So I will now switch this. I'm gonna control the guy on top of the elevator, because that's the guy that I have on the server. So you guys shall be able to see the transition. So let me see here. So yeah, I'm controlling it here. So it looks kind of correct, right? So I'm gonna jump out of this here, and because I'm gonna jump, I'm gonna be fully snapshot again. I'm now a snapshot. And let me go somewhere you guys can see me. So I'm fully snapshot smooth, and I want to confirm I'm actually a snapshot interpolation on the server here, which is I want to see. So oh, please do not disconnect. Please do not disconnect. Is that my character? Yes. Yeah, it's forced snapshot here. So it does work. Okay, nice. So I'll switch back to the server here, and I'm gonna control that guy again, and I'm gonna put myself on top of not the elevator, but the horizontal moving platform, and that's gonna be looking perfect. So I'm gonna push this guy out. Come on, leave. Yeah. So let's now switch back to the client, which is the editor, and let's see how that guy looks. Yeah, so that's a real player, and although the horizontal movement is not predicted, the platform movement is fully predicted. And I'm gonna switch back to the client here, because I want to move that guy while the platform movement is predicted, to see how it looks on the transitions. It looks correct. It's not bad at all. But we are losing some of the lag compensation accuracy here with this hybrid solution here. But visually, honestly, this is the best you can do, which is you're switching the interpolation, not only the visuals, but you're switching the simulation and the interpolation mode of a remote player from time A to time B on the fly, just because he's on top of a moving platform. Does this all make sense to you guys?
Yeah, it's looking good.
Yeah, it's not bad, right? So I have a confession to make. I haven't tried anything. This hybrid code I just did right now. I just had thought about the idea, but I have never implemented this before. This here. I mean the hybrid idea that when I'm on top of moving platforms. I've never done this before. So it does work. And I think and the glitches we saw on the elevator, they are fixable. Elevators are sometimes tricky, but it's fixable with an extra shape overlap, so you don't lose the grounded state, and then you can keep predicting that you are still on top of a platform. So that will also influence the solution for animations, not losing the state in that case. But yeah. So one thing I didn't show, maybe you guys realize how I do this, but let me show exactly how it's done. So how does the character move on top of how does the character control, how does the platform can move the character at the same time? What I do is I store a platform movement velocity. So remember, the script that moves the platform, it always runs before all the players are moved, and I update the velocity. If I need to clamp and invert, I apply the transform with the new velocity, and the stored current velocity is always the updated velocity. So when the player movement code runs, that it calls this here passing the callback object. The callback object here is the weapon script here, because I needed to use this for the trigger to collect the ammo stuff, so I just reused it here. So on an actual solid collision, I'm checking if what I'm colliding with is a platform. If what I'm colliding with is a platform, I'm setting this variable here on the player movement. So on player movements, what I do at the movement is I always reset this. So this is not a network variable. It's not state. It's always computed when I'm predicting movement. So I always reset, and when this is called, that callback takes place, and this value is set. And then here's what I do. I compute the movement of the character is actually the actual character controller movement plus whatever is the velocity of the platform you're on top of. Whatever the direction is, vertical, horizontal, diagonal, whatever it is, it's going to be integrated together with the actual movement. And that's it.
Does that need to be an actual grounded check, though? Because it seems like proximity isn't...
No, it's not. There is no ground check. Oh, yeah. You are correct, Devin. Sorry. Here, I should... this is kind of like... This would also work if I touch it from the side. So I should technically check other dots. So we have the normal of the collision with the platform. So I don't think in this version of the character controller I already passed. Oh yeah, this is a ground style collision, but you can compute here the angle of the normal of this collision to see if it's a vertical ground from the bottom collision, right? So you can get that information here, and then you do this if you're touching the platform from the bottom. Okay. It's easy to solve. I'll finish the code for that in the simple, but we don't have to do it right now if you guys allow me not to do it right now. What was that you asked, or something else? Devin, or maybe you went to make coffee.
I was looking for the window. I had to find the window to open the chat. Yeah, I just want to make sure it was actually accounting for that, because if you're hovering above it or something and you have if you're using an overlap, it would suddenly start moving you even if you haven't landed on it yet. Was the only thing that I was
but this overlap is no, so you asked something else. No, this overlap is very, very close to the actual collision, but it does need to give you this extra. You still land, you still move to settle on top, but you have to receive the grounded state a bit before, otherwise every little bump on a thing that looks kind of like a horizontal surface would make you lose the grounded state. And that becomes a challenge not only for moving platforms like this, but also for animation. Because when you're not grounded, you may be switching to the jumping animation. So
would it not just be pulling the value from the character controller? Because it seems like the character controller is a pretty good idea of whether or not you have ground contact.
Yes, but I need to know if the ground contact is indeed a moving platform or not something else, because I need to read the data about the moving platform, which is what's the current velocity of the moving platform, and that I can only do from the callback, because I need to...
Would that be something we might want to add into the character controller system as like a thing that you stick on moving platforms so that the character...
This is a broad question, Devin, right? So the advanced character controller may have an implementation of this because it's not only a character controller, it also includes the implementation of moving platforms, right?
Yeah.
But not on this one.
Yeah.
This one is a bare
I'm not actually not disagreeing. I'm just kind of wondering if there's a way we can simplify this, because
it does make sense to solve this in a more generic way for, let's say, a ready complex character controller like the advanced one that Theory works on. Yes.
Cool.
Yeah, that's a good...
That was my question. You got it.
It's
Thanks.
a good point, yeah. So, yeah, but you guys see it's actually quite simple to make a super smooth moving platform for a local single player kind of game. And it's not that much difficult to make it work for an online game. The problem lies somewhere else. The problem lies on the timing. And then it becomes your decision. What I showed here was all the options I know of, and all the variations, all the combinations, which is you either place everything on B timing, quantum, or you place, when using dual timing, you have to choose which one of the timings you're going to place the platform at. Honestly, I think platforms have to be together with the local player. But to have a complete setup, you actually switch these timings both on the platforms and on the remote players based on the distance they are from the local character. Because you want far away characters and platforms to be on this timing here, so you get full like compensation, accurate working all the time. Close characters, you may want to place everything on this. Not the full prediction of the movement of the characters, but Alex, this one is for you. So technically, if you're gonna do full prediction of the other players' movements, you may either place everything on B, although for a shooter it's not what people like, but it would let you do everything on full B timing if they're close enough to the player, for example, because then lag compensation is less important. But I hope I was able to explain and show all the options to you guys. And as I said, I recorded this video on the actual full resolution here, and we'll see how we can make it available for you guys on the closed circle. So I still have time for a few questions if you guys have any. So
yeah, I've got a quick one. Would any of this apply to a conveyor belt sort of setup, or is that way simpler?
A conveyor belt is a bit simpler because a conveyor belt does not move itself, right? So a conveyor belt, you can... I've done a conveyor belt on a quantum game, but that doesn't really matter for this context here. So say if you want to implement a conveyor belt on something like this, it would be a collider that has a component that tells what's the direction of the conveyor belt.
Mm-hmm.
And that's gonna do some trick on the rendering of the conveyor belt, of course. But the object itself does not move, right? And because the object itself does not move, it removes the challenge of what should be the timing of the conveyor belt. The point is there is no timing on the conveyor belt. The conveyor belt, what you can have is it's either running or not running, or maybe it has a different speed, but that's less of a problem. That's not super bad problem. It would only be more a problem when it switches, but a moving platform is a problem because of the times at which it changes the direction. So you saw very clearly on the elevator that the guy on the remote guy, if the ping is big enough, it's gonna dive, it's gonna sink into the elevator or float on top of it when going down because he's on the past. So yeah, but on a conveyor belt that doesn't happen, so it's easier.
Cool.
So let me see if I... Okay, so that was not really a question. Okay, guys, so if there are no other questions on the topic, thanks a lot for you guys watching here. It was cool. It's a different format, and I feel much better being able to go very deep and saying everything we can. And let's see if we can do this again on Friday. I'm gonna search for a topic. If you guys want to suggest any of the topics, especially the ones who have been following the stream.
Can you show the list again?
Yes, it's here. So this is what we've been discussing so far. So there are a few. So this is what I wanted to do. So moving platforms done. It's been a long. For a long time it's been a requested topic. So let's see. These are just. So there are a few interesting topics like how to do a rigid body like grenade. So let's see a few options for this.
Yeah, I think I'm interested by that one and the shotgun, like the different options for implementing the shotgun. Like maybe not using physics bullets, you know, or some, I don't know, maybe a cone or some ideas.
Yeah, cone is interesting. Yeah, the thing is that ideally, to do a shotgun with a single check, to be very accurate, we should have at least a shape cast. A shape cast would be a good approximation for a shotgun, because we could shape cast with a sphere, and we could increase the size of this sphere as the shotgun bullets travel. And for shape casts, Daniel is here. So we plan to have lag compensated shape casts as part of the lag compensation system. It's just not yet there, but we'll do it, and then it will be much easier to do like that. But we can approximate for now with a sphere shape, but it will not. It will not be ideal because we need to move this shape very fast to be a bullet, right? So the ideal solution for a lag compensated shotgun with a single query is a cast, a shape cast.
Yep.
Okay, but it is, yeah, these two topics, like how to implement different ones. Another another super interesting topic is shooter on a vehicle driven by another player. So this one is interesting because it has to do with timing as well.
So you're only going for the tricky ones.
Yeah, I like the tricky ones. Yeah, this one here is cool. I mean, but I will do it with actual normal bullets that are like compensated raycasts. First, because the system is fast enough to do it. So our lag compensation system is really fast, so you can have a lot of small shotgun pellets.
You've talked about it.
Yeah, but I will implement it with a shape cast as soon as we have a shape cast as well. definitely, because that's the right way to do it. And yeah, and this one here is cool. We can do it already. I'll see. I'll show you guys how we can do this one here. Okay, so thanks again. I'm gonna be finishing for now, and I'll let you guys know when it's the next one, probably on Friday, but I'm gonna decide on the topic, and you guys can still suggest me anything else. If you guys see something interesting that you haven't thought about before, just let me know. Okay?
Sure.
So
Thank you very much.
Yep.
Are the previous videos on
They're
Twitch?
still on Twitch. They're all on
Okay,
Twitch.
cool.
And I'm also downloading all of them, so even if I remove from Twitch, and when Twitch removes them, we still all have all of those. So if they're interesting enough, we may make them available. So we'll see.
Cool.
Okay.
Cool.
Bye.
Thank you.
Thanks a lot.
Cheers. Bye bye.